distribution of various orbits of energy levels can be calculated by the formula 2n square. Here n denotes the number of orbits. The number of electrons in k shell in the first orbit can be calculated when k is equal to 1. Use 2n square formula, substituting the value of n. When n is equal to 1, you will get the maximum number of electrons in first orbit is only 2. Suppose in the next principal orbital, the next energy level, next higher energy level, L is equal to 2. Similarly, using the same formula 2n square, then substituting the value of n, that is equivalent to the maximum number of electrons in the orbit is 8. Now, here the typing mistakes is there. This is the first orbit, this is the second orbit, this is the third orbit, and this is the fourth orbit. I am apologizing you for typing mistake. This is very important. Please correct it as first orbit, second orbit, third orbit, and the fourth orbit. The distribution of electrons taking place is k shell is 2, L shell is 8, M shell is 8, and N shell is 32. This is 18. This is 18. Again typing mistake. I'm very sorry. Now, so another important thing is that, my dear friends, electronic configuration using Aufbau principle, total number of electrons in the principal energy levels, which is K, L, M, N, that is 2, 8, 32, and that 18 and 32. It's very important in the distribution of electrons. Aufbau principle. The Aufbau principle from the German Aufbau Principle, also called the Aufbau rule, states that in the ground state of an atom or ion, electrons fill atomic orbitals of the lowest available energy levels before occupying the highest energy levels. For example, 1s subshell is filled before the 2s subshell is occupied. These electrons occupy the first lowest available energy levels before occupying the higher energy levels. First 1s, then after filling up 1s, it should go to the 2s, and after filling 2s, it will go to 2p and 3s, and after filling 3s, again it will go to 3p and 4s, and 3d, 4p, 5s, and so on. Yes, friends, this is, please take it as a home assignment for the practice purpose. Write the electronic distribution of various orbits for the following elements. I have arranged 1 to 10 for your kind information. Using Aufbau principle, you please write down the distribution of electrons is nothing but the electronic configuration for hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Up to that time, you can consider increasing order systematically. Hydrogen 1, helium 2, lithium 3, beryllium 4, 5, 6, 7, 8, 9, 10. You can write down another important electronic configuration of the following elements like sodium, chlorine, potassium, calcium, magnesium, iron, aluminium, using the Aufbau principles. Quantum numbers allows to define the location of the electron within the atomic structure. Within each shell, we find subshells that have different shapes depending on their energy level and thus can fit a different number of electrons. They are named after the letters S, P, D, F, and so on. These subshells are second quantum number and are numerically defined as follow. Letter L is equal to level L. S is 0, P is 1, D is equal to 2, and F is equal to 3. Calculate the number of orbitals by the equation 2L plus 1. Thus, in the S shell you will have 2 electrons, P shell you will have 6 electrons, D shell you will have 10 electrons, F shell you will have 14 electrons, which will give the distribution of electrons in the hybridization of orbitals, which is S, P, D, F orbitals. Like, share.